Welcome America, welcome Justin Bieber. Today we're going to be reviewing for our second log test. So we are going to do, I will attach the worksheet. We're going to do problem 14 on this review, and then I think we're going to do problem 5 on the next page. This page is called, which one is this one? This is the solving page, and we're also going to do problem number 14 on the solving page, and problem number 5 on the properties page. There we go. Okay. So, the directions for this problem say solve the following equations, use your calculator to find the decimal approximation for the answers. Okay, someone else is going to have to do that because I don't have my calculator pulled up, which is fine. All right, writing. Okay, so we've got this equation. We've got two different bases. We can't really change the bases, the 3 and the 2, into the same bases. You know, if this was a 9, we could change that into 3 squared and then set the exponents equal to each other. We can't do that here. And our unknown is in the exponent. So what we can do is rewrite these as logarithms and then pull the exponents in front. So we can get the exponents or the variables out of the exponents and then solve for them. Because we really need to just isolate that x. So it's going to be a little bit of work here. If you log both sides, you can, log base whatever you want, but it has to be the same base on both sides. And usually when we do that, we just usually do natural log is the quickest way, ln. So it looks like this. Natural log of 3 to the x plus 1 equals natural log of 2 to the 4x. So we did that, you know what that says. This is hard to read, but now I can take those exponents and move them into front as coefficients. So this becomes x plus, x plus 1 natural log 3 equals 4x natural log 2. So now we have, this is a number and it's being multiplied by the quantity x plus 1. So we're going to distribute this number to the x and to the 1. Here, these are being multiplied, so that's just one term. So this becomes x natural log 3 plus 1 times natural log 3, which is just natural log 3, equals 4x natural log 2. Okay, so now we've got 3 terms, and we've got 2 terms that have x's in them. So we're going to take those terms that have x's, move them to the same side, and then factor out the x, just like we did last class. So it's manipulation, algebraic manipulation. So I'm going to keep the natural log 3 on this side, and I'm going to move the x, I'm going to subtract the x natural log 3 from both sides. So that on the other side will be 4x natural log 2 minus x natural log 3. Now, any questions so far? Okay, this is the tricky part that we always have trouble with. Each of these terms have an x in them, and x is what we're looking for. We need to isolate. So we are going to factor out, or GCF out, an x, and everything we have left, we're going to divide both sides by to isolate that x. I'm running out of room. Natural log 3 equals x times everything that's left, so 4 natural log 2 minus natural log 3. That's just a number. So now I can just, trying to make myself space here. Okay, now I can just divide both sides by 4 natural log 2 minus natural log 3. And you just have to be careful when you type it in the calculator. Maybe I should do that. All right, I'm going to pull up my 83. Where is it? I highly recommend the background, dogs in costumes. So fire. Okay. And there's so many of them too. Every single one is amazing. Okay, clear. All right, what were the numbers? Natural log 3. This is much easier on Desmos, by the way, because it creates the name column for you. Natural log of 3 divided by, and then I've got to put a parentheses because I'm, if you're using Desmos, it's easier. Tell me if I make a mistake here. I think these are the right numbers. Here we go. And that's right. Did you have a question for me, or was that for
mine just errored, you know?
We'll just try it again. Make sure if you do this on Desmos, it creates the VIN column for you, and then you can type this in the denominator. But just be careful. Don't be careful, but whenever you're using, you know what? Let's just pull it up, and I'll just show you because we have time. All right, so let's see, where are the functions here? Do we even have logarithms on this calculator? Gracie, have you tried this? Here we go.
Wait, we were supposed to get a Desmos.
Try Desmos?
Yeah, you said you were going to use Desmos.
Yeah, I use Desmos all the time. Love Desmos.
Did you get a
Natural log 3, close parentheses, and then divided by, and so when you do this in Desmos, it creates that VIN column for you. So you don't have to worry about putting your parentheses.
I'm not special enough for the Virginia Desmos. I can never look at Virginia.
I just pulled up the Standards of Learning one because I just already have it bookmarked, but the one that we would be using in this class would have a black bar across the top that wouldn't say Standards of Learning. It's really similar to the SOL one, and for this problem it's not going to be any different, so there we go. So you can see, same answer. Questions? All right, good times. Yes, Eric.
Do you always use natural log for these problems?
You can, okay, so for this kind of problem, where am I at? Where's the flip chart? Here we go. You can log both sides however you want, as long as the base is the same. So you could do log base 10, you just do log both sides. It's fine. We usually just use natural log because it's the quickest, but it doesn't really matter. Was I gonna do one more problem? We still have 8 minutes. I think it's not bad to review condensing.
Can you round the decimal if you want to?
Yeah, what do the directions say? Use a calculator to find the decimal approximation for the answers. It doesn't say, but usually in pre-cal we try to round to the nearest 1,000, so 3 decimals. Okay, number 5. So we've got some leading coefficients here that we can make exponents. Let's go ahead and do that. Natural log of x squared minus natural log of x to the 4th minus natural log of y plus natural log of z squared. Now, all the subtraction, following the log properties, will be in the denominator, and all the addition ones will be in the numerator. So this x squared will be in the numerator, and the z squared will be in the numerator. So let's just see what we get and go from there. So natural log, in the numerator we've got our positives, x squared and z squared. In the denominator we've got our negatives, which are x to the 4th and y. Now, we're almost finished, but in the numerator and the denominator we have x squared and x to the 4th. Do you guys remember how to simplify that from algebra 2? I'm going to go with no. What this means is x times x over x times x times x times x. So one of those can cancel, and that's why you can subtract. If you have the same base, you can subtract the exponents. So you can think of this as x to the 2 minus 4, x to the negative 2. And then therefore those x's will be in the denominator. Did I explain that well enough? So this equals, I'll just do it over here. X to the 2 minus 4, that equals x to the negative 2, and that equals 1 over x squared. Should I explain this?
Yes.
Okay. I think I did this on the board for you guys a while ago, but it can't hurt to go over this again. I need a blank space. All right, so if you got 10 squared, that's 10 times 10. You've got 10, that's just a 10. You've got 10 to the 10 to the 0 power, that's 1. 10 to the negative 1 is 1 over 10. And 10 to the negative 2 is 1 over 10 times 1 over 10. It's 1 over 10 squared. So that kind of gives you an idea about where these numbers are coming from. So anytime you have a negative exponent, you can have this change floors. Right now it's in the numerator, it can be in the denominator, and it can have a positive exponent. So if you had a negative exponent in the denominator, you could have it change floors and make it a positive exponent. So we're dividing by 10 through each of these. So if you divide 10 squared by 10, you get 10. If you divide by 10 by 10, you get 1. That's why 10 to the 0 power, anything to the 0 power is 1. If you divide 1 by 10, you get 1/10, which is why 10 to the negative 1 is 1 over 10. How am I doing? Are we done? Good times. All right, no questions?